All right, and so I'll go ahead and summarize then what we kind of figured out from that GeoGebra activity, and we'll talk about the corresponding angles. Postulate. Now remember, a postulate, that's something we just accept to be true, right? It doesn't need to be proved. It's something we kind of accept to be true. We kind of see it evidenced, you know, from our little activity there, from our little like examination, right? And so we say, okay, yeah, this is probably true. And so we start off with that being true. So if two parallel lines, okay, are cut by a transversal, then corresponding angles are congruent. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Will this be true if the lines are not parallel? In general, yeah, Evan, right. No is the answer. They won't be, right? And we can see that. If you just go back to your Chromebook real quick, right, and if you, like, make the lines very clearly not parallel, whoop, that's the wrong thing. If you make the lines very clearly not parallel, okay, I mean, they're clearly not parallel, and clearly the corresponding angles there are not congruent, okay? So that's the gist of it there. Let me see if I can get it back to where it was. There's something. What's that? Oh, that's a good idea. I like that. There we go. That works. That's much more speedy. Thank you, Evan. Okay, so that's a postulate. What about now alternate? What about alternate interior angles then? So let's go back to our Chromebooks, okay, and maybe delete out those corresponding angles, okay? So actually I should probably go back. So let's look at alternate interior angles, one of our other angle pairs here. Okay, so I'm going to delete out these angles by selecting the angle, okay, and then hitting the delete button, or you can like two-finger tap it if you want to as well. Okay, so I delete those angles, and now I'm going to pick a pair of alternate interior, and you guys pick a pair of alternate interior as well, okay, and measure those. So let's see here. Maybe I'll pick this one. Oop, that's not the way I wanted to measure it. Let's try this way. Okay. Ooh, when I say counterclockwise, clockwise, so this is okay. So again, alternate interior angles. There's a pair right there. And if you want to move your angles around, if you just like, here's like my measure. If you click on it and then drag it around, it can drag around to nearby the angle. I mean, it won't let you go too far. I can't like pull it all the way away, but like it drags to around there, so if you like just to see it better and stuff, you can kind of maneuver it around some. Okay. So what does it look like is true here? They're going to be what? Congruent. That's right. So it looks like if we have two parallel lines cut by a transversal, then alternate interior angles will be congruent. Okay? And in fact, that's correct. But this thing is a theorem, which means it must be proven. And we're going to do that. Okay, we're going to do that. So let me draw a picture here. Okay, just for our own benefit of the proof. Okay, and I'll have my little transversal drawn right there. Okay, and I'll number these. I'll call this, I don't know, I'll call this like line A and line B. Okay, and notice that I indicated these two lines are parallel, even though my terrible sketching skills there doesn't make them look very parallel, but you see that they're marked that way, so we'll just take my word for it. And I'm going to number my angles here in an odd way. Okay. Okay, so the alternate interior angles theorem is this. If a transversal cuts two parallel lines, so it's pretty much, same kind of start as the other one. If a transversal cuts two parallel lines, then the alternate interior angles are congruent. Okay. Now remember, we do have correspondent angles already, right? That's given. So we can use that in our proof here if we want to. Okay? So, our given in this situation is that A is parallel to B. Okay? We also have these little markings for the names of the angles in here, but that's not so important. I mean, we can kind of name things however we want. But the fact that these two lines are parallel, that's important. We need that given to us. And we want to prove, in this case, we'll just prove one pair of alternate interior angles because the other proof is very similar. So we're just going to prove that angle 5 is congruent to angle 6. Okay, so those are certainly alternate interior, but the proof for 1 and 2 will be exactly the same. Well, not exactly the same, but I mean, it's, similar, I should say. Okay? All right, and so I'll go ahead and I'll give us the statements here. So here's going to be the proof over here. So I'll give us the statements, and then we'll kind of try and fill in the reasons. Okay? Well, hopefully we all know what's the first step, or what's the first statement going to be. Right, the reason is given, but what is the first statement? What was Evan? Yeah, go ahead.
A is double line to B.
What does that double line mean? Anybody, what does that mean? Yeah, Mary. Parallel, that's right, yeah. A is parallel to B, that's our given, okay? Very good. All right, so then our second statement I'm going to give us here, angle 6 is congruent to angle 7. Okay, now what piece of information do we have that says that angle 6 is congruent to angle 7? How do we know that is true? What piece of information do we have? What allows us to say that? Tanner, yeah?
Corresponding angle postulate.
Exactly, right? What are 6 and 7? 6 and 7 are congruent because they're corresponding, right? And we're allowed to use that because this is a postulate. This is something we just accept to be true. So we can use that any time we have that, show up. And so in this case, yes, corresponding angles I'm going to abbreviate postulate because, gosh, there's a lot to write. Okay? All right, next thing we're going to say then, if we know that 6 and 7 are congruent, we also know that angle 7 is congruent to angle 5. Okay, and how do we know that angle 7 is congruent to angle 5? What kind of property makes angle 7 and angle 5 congruent? What angle relationship do we have there? Yeah, Evan. 7 and 5, are those alternate interior?
Oh, no, they're
And what makes 7 and 5 congruent?
another word.
All right, it's escaping you. Someone rescue. Ah, there you go. Yes. That's vertical angles. That's right. Vertical angles are congruent. Okay. And so let's kind of refresh our memory. So again, our goal is to say that 5 is congruent to 6. So far we said angle 6 and 7 are congruent. Then we said angle 7 and angle 5 are congruent. So again, 6 is congruent to 7, 7 is congruent to 5. So we can finally say that angle 6 is congruent to 5 by what? So 6 is congruent to 7. 7 is congruent to 5. How can we finally say that 6 and 5 are congruent now? What are we going to use? You can see it right here. Angle 6 is congruent to angle 7. Angle 7 is congruent to angle 5. What makes angle 6 congruent to angle 5 then? Patrick, you have an idea? Yeah, transitive property. I would also accept substitution property there, but transitive property. Because look, here we have 6 is congruent to 7. 7 is also, though, congruent to 5. So if 6 is congruent to 7 and 5 is congruent to 7, that means 6 and 5 must also be congruent. And therefore, we have what we were trying to prove. So we're done. Okay, so there's our little proof. It's not too shabby. Okay. I'm going to have you guys prove, let's see here. Oh, we got one more here. Yeah, okay. Okay. So now we're going to look at alternate exterior angles. All right, so let's get this up here some. Okay. And you can go back to your picture here. Okay, go back to our Chromebooks. Oh, I wonder what that would look like. Oh, that's interesting. Okay. So anyway, that, by the way, that's like my recording program that I use to get the stuff. So anyway, if you ever watch the YouTube videos. So let's see here. So let's see. Pick my angle out. Get that. Delete it. Get that. Delete it. Okay, so now we should measure some alternate exterior angles. So let's get that happening here. So let's see. I'm going to pick, I'll pick this one. Let me see. I think I'm going to try this way, this way, this way. Good. And let's see here. This way, this way, this way. Good. Alternate exterior. And again, what does it look like is true here, right? What do we think is true? If we have two parallel lines, or basically parallel lines, right, here, cut by a transversal, what's going to be true about our alternate exterior angles? They're going to be what? Congruent. Exactly right. Yep. So let's see here. So back to, and hopefully you guys all got that same thing there too with yours. Okay, so that's exactly right. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. I'm just going to use a congruent symbol there. Okay? Okay, I think I leave that to you guys as a proof for homework. And it's like a fill-in proof. It's not like you do it all on your own. You fill in the reasons, I think, for the most part. There might be a few statements you fill in, but mostly you fill in the reasons. Okay, so that proof will be saved for homework. And then we have one more. We have one more angle pair relationship. Okay, and what is that angle pair relationship? Let's go back. So we've talked about corresponding. We've talked about alternate interior. We've talked about alternate exterior. What's the last one we have to look at? We haven't talked about yet. What's the last pair in these kind of situations here? Remember? So, you know, alternate interior, alternate exterior corresponding, and yep.
Linear pair?
A linear pair? Okay, so we do have linear pairs in here. I was thinking more along the line, but linear pair, you don't need to have these two lines cut by transversal to form it. So there's a special, actually go to Tanner, yeah.
Co-interior, like,
Yeah, co-interior, or also called consecutive interior, or sometimes also same side interior. So that would be like, for example, this angle right here, and this angle right here. Now, I can kind of look at this right now, and does it look like angle D, in my picture, does it look like angle DFE is congruent to angle FEB? Does it look like this angle is congruent to this angle? Yeah, no. So why don't you go ahead and measure, pick two same side or consecutive interior or co-interior angles, pick two co-interior angles, and measure them, and see if you can come up with some relationship here. So I'm going to do it. Boop, boop, boop. And then boop, boop, boop. Alright, I'm not trying to do that. So anyway, so clearly they're not equal, right? Is there a relationship here, though? Yeah, Tanner, what do you think?
complementary.
So that means they would add up to what?
There's some right there.
That means they would add up to what?
180.
180. That's right. Yes, exactly right. These guys are supplementary. They should add up to 180, and that's exactly right. Okay, so co-interior angles should add to 180 degrees. I used to be able to, on another program that I did, I used to be able to show it to add up. I don't know if I can, like, yeah, no. There used to be a way where you could, like, show the sum of two angles and stuff like that and manipulate around, but I haven't figured out how to do that yet. I have to play around with this. But anyway, yes. So back to our notes here real quick. So, same side or co-interior, okay, or sometimes also consecutive. There's lots of different names for these things. Same side, interior angles, okay, theorem. Okay, I ran out of space here. Okay. So again, if a transversal cuts two parallel lines then what can we say? The transversal cuts two parallel lines, then the same side interior or the co-interior or the consecutive interior angles are supplementary. So I'm going to say same side because that's what I started with here. Same side interior, okay, angles are supplementary. Ugh. Okay. All right, so let's do a little practice here. Okay, so I'll kind of scoot this up. Okay. So state the postulate or theorem that justifies the statement. Okay. So I'll draw a picture here for us. And let's see here. And again, if these are real, kind of simple, don't worry too much about this. And if you feel like you got it, I don't know if you need to write this part down if you don't want to, but just follow along if nothing else here. Okay, but there's our picture. So, we got two parallel lines cut by a transversal. All right. We don't look at the picture and say, oh, these lines are parallel because it doesn't look like they intersect. We know the picture. We know they're parallel because they're marked that way. That's what's most important. Okay. We got our cluster of angles up here and our cluster of angles down there, and they're not really numbered in like a particular order, so we just want to make sure we keep that straight. So now 6 and 7, okay, we're saying that 6 and 7 are congruent. So what postulate or theorem justifies the fact that those are going to be congruent, 6 and 7? Which one of our previous ones there would guarantee that they are going to be congruent? So yeah, Mary? Exactly right. These are corresponding angles, so they will be congruent by the corresponding angles postulate. Okay, good. How about angle 5 is congruent to angle 6? So 5 and 6. What theorem or postulate can we use there to say that they are congruent? Yeah, was it? Exactly. And you can abbreviate too if you want to here. So I'm just going to put like alt, int, angles, theorem. You can like abbreviate theorem, THM. Okay, that's a lot of, saves you a little bit of time, right? Makes it a little bit easier. All right, and you guys, I want you to try the last two here. So go ahead and take the last two. So I'm going to give you angle 4 is congruent to angle 7, and I'm also going to give you the measure of angle 1 plus the measure of angle 5 is equal to 180 degrees. So again, think about what's the postulate or theorem we can use to say that those two things are true. And I'll kind of move this up here. So how can we say that angle 3 is true, and how can we say that angle 4 is true? State that postulate theorem. Okay, so 4 and 7. What's the reason for that there? What's the statement? Yeah.
Alternate exterior angles.
Alternate exterior angles theorem. And how about number 4? What's that one? That's not one of, well, it could be one of our angle pairs. What about angle 1 and angle 5 that must equal 180 degrees? Yeah,
Consecutive angles.
yeah, exactly right. Consecutive, co-interior, same side interior, whatever you want to say there, one of those two. I'll use co-interior here. Well, why not? Co-interior angles theorem. Okay, lots of different names for that one type. Or same side interior angles theorem, whatever you want to say. Okay? Alright, so of course, along with that, right, we have some algebra we can do with these things too. Right, so for example here, let's say we're going to find the value of x in each example. Okay, so let's see here. Okay, so we'll have these two parallel lines drawn here, and I'll label this angle. I'll zoom in on that some more because it's kind of small. So in this situation, how might we set this up to be able to solve for x? What can we do here? Yeah, Stephanie.
Can you do 7 minus 16 plus 55 equals 180?
Exactly right, and that's because these two angles are, what's the special angle pair there? What's that? Same side interior, co-interior, yep, one of those two would be fine. Yep, exactly right. So you have 7x minus 15 plus 55 equals 180. Okay? Exactly right. And so you combine like terms there, so what, that would be minus 15 plus 55 would be 40. So 7x plus 40 equals 180. Subtract 40 from both sides, you get 7x equals 140, and so x is 20. Okay? So there you go. That's right. Yep. Okay, cool. Let's try another one here. So any questions? It's pretty straightforward, I think, yeah, using those relationships. Okay, let's try another one here. Let's go to, let's see. And okay, so those two. Oops, I should probably also draw. There we go. Now I know those two lines are parallel. The equation we can set up here. What is it? You got it, exactly right. And that's because this special angle pair they are what? They're going to be equal. What's the name of it though? They are, yep, exactly, alternate interior. So we have x on both sides, so subtract 2x on both sides. You get 50 here equals x minus 30. Add 30 to both sides, you get x is 80. Okay? Pretty straightforward there. Alright. So there you go. Basic kind of stuff, right? Just use those angle relationships to set up the equations and then solve for your x in this case. So, any questions on that? All good. All right. So let me give you guys the assignment then, and you get started on that. You can also put your